In today's session, we're going to be looking at the final abstract data type for A2 level, and that's called a graph. Now, you've already encountered graphs when we were looking at artificial intelligence, so provided that you understood how graphs operated, this would be a very quick lesson. Another advantage with regard to graphs is that we don't need to code a graph in either paper 4 or work with pseudocode in paper 3. So all you need to know here is just a bit of theory. You should be able to show understanding that the graph is an example of an abstract data type, and you should be able to describe the key features of a graph. In addition to that, you should be able to justify the use of a graph for a given situation, for a particular type of scenario. A simple example here would be that if you are creating a navigation system, what kind of abstract data type would you use? Well, quite clearly a graph would be very suited for that particular situation. So let's start by looking at what graphs are. They're a non-linear data structure. Arrays would be a linear data structure because everything follows in a sequence. So nodes in a graph can be related to any other node. So it's non-linear, it's made up of nodes and edges, and it can be both directed or undirected. Now, if it's undirected, you're probably going to be using Dijkstra with it anyway. And if it's a directed graph, chances are you're going to be using an A-star algorithm. On screen, you see an image of what nodes are. Normally they are circles, and the edges are the lines that connect them. And what do we mean by directed graphs? Well, a directed graph will have a direction from one node to the other, and normally this is indicated by an arrow. Now, we use graphs for mapping bus routes, train journeys, website links, social media, networks, route finding, and so much more. You can even link DNA relatives to each other. Graphs can be used in history, medicine, you name it. As long as you can establish a relationship between two parties, chances are it could be represented as a graph. Now, on screen, you can see an example of a graph, which is a bunch of locations in a town. And you'll notice that each edge has a weight, and this weight can be a distance or a cost or a rating. In our case, we could just simply say that this could be the distance, for example, half a kilometer between the town center and the shopping center, and so on. There's some additional technical terms that are associated with the graph, and these are called paths and cycles. A path is a list of nodes connected by the edges between two given nodes. So a path between the town center and the train station could be direct, or it could be via the school. So you've got town center, school, train station, or it could be via the river, town center, river, train station. So that's a path. A cycle, on the other hand, is a list of nodes that return to the same node. So if you wanted to go to the town center, then go to the train station to pick someone up, and then come back via the school back to the town center, that would be a cycle. So town center, train station, school, and town center would be a cycle. So in a cycle, you always return to the same node. A path doesn't return to the same node. Putting all the abstract data types we've covered so far together, you also need to know the uses of stacks, queues, and linked lists, and similarly binary trees and graphs as well. Now, stacks are used in memory management, expression evaluation, and backtracking in recursion. Queues are used to manage files, to things like printers, scheduling, buffers. Linked lists are used to actually implement other abstract data types. For example, you can use arrays to implement a stack, or you can use arrays to implement a queue or a binary tree. Graphs are normally implemented using 2D arrays and, of course, linked lists, and we're going to look at these in a moment. However, implementing graphs is beyond the scope of the syllabus. We don't need to know how to create those. We will talk about them, but just be aware that these aren't actually needed. So how do you implement a graph? Well, we can implement a graph using something called an adjacency matrix, which is your two-dimensional array, or an adjacency list. An adjacency matrix stores the relationship between every vertex or node to all the other vertices. For an unweighted graph, a 1 represents an edge, a 0 represents no edge. When weights are to be recorded, the weight replaces these 1s. Now, instead of a 0, we often end up using an infinity symbol for a weighted graph. Now, if you look at the weighted graph at the top, A, B, C, D, E, and F, we can create a matrix, and the distance between A and B is 3, but the distance between A and A, which is basically 0, is represented by an infinity. So it's pretty straightforward. All you need to do is just have the column headings and the row headings, and then just map the distances between them. And when we look at an adjacency list, it stores the relationship between every node to all the other nodes, or every vertex to all the relevant vertices. And entry is made only when there is an edge between two vertices. So if A and B have a connection, we list that along with the weights. So in this case, A, B3 and D5, because that's how those are connected to each other. If there is no relationship, for example, between B and F, there is no direct route, therefore we do not represent that. Now, once again, implementing graphs is beyond the scope of the syllabus, so you don't necessarily need to know how to implement these. What you do need to know perhaps is how to draw things out. So this type of question could be quite common. So here's a task for you. Draw the labeled edges for a directed graph of a road system where A to B is 2 kilometers and it's a one-way system. In this particular case, you'll just draw a line between A and B. The direction will be from A to B and the weight will be 2 kilometers on the edge. Pause the video and have a go. This should be a pretty straightforward task. That's it for today. Hopefully you understand what a graph is and what the difference is between a path and a cycle. You should also understand how different abstract data types can be used to create other abstract data types. And you should also be able to create a labeled graph based on a scenario. If you do have any questions, please do get back to me. Otherwise, I'll see you in the next one.